Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of triangular prisms, specifically how we can find the volume of these three-dimensional solids, and we will do it in 5 minutes or less. So our equation for volume of a triangular prism is actually the same as our equation for volume of a rectangular prism, or any prism for that matter. It's base times height. Now the difference is the base is going to change based on what type of prism we have. So in our triangular prism, we are going to use our triangles here as our bases. So we've got two triangular faces right here. We're going to count those as our bases. And then we've got three rectangular faces that connect those two. So imagine we are rotating this about 90 degrees counterclockwise. We're going to sit it up so that we're actually sitting on one of these triangular faces. So we're going to count that as our base, which means if this is at the bottom right here and this back one is at the top, that means this is actually going to be our height, because that's actually connecting the two triangular faces. So the height doesn't always necessarily mean from bottom to top. It just depends on how you happen to be rotating it. And so this is going to be our height right here because it's connecting our two bases. And so we already have that. Volume equals, let's call that 18. Let's just go ahead and flip that using the commutative property. 18 times b, which is our base. Now, we need to figure out what the base is. So the area of the base, remember the area of a triangle, and so we'll remember that area of a triangle is 1/2, and it's kind of confusing because we have another base times height, but we're just trying to actually find the area of this triangle. That's really the trickiest part. Once we find the area of the triangle, that becomes the base of our rectangular prism or our triangular prism or hexagonal prism. Whatever prism you're looking at, that becomes the base. You simply multiply it by the height. So for our triangle here, our base is actually all three. You notice all three of these are actually on the back end. So we're going to bring this base right here, since we've got this height perpendicular to that. So we're going to say this is 8 centimeters. So our area of a triangle is going to be 1/2 times 8. Now, since this is not a right triangle, they have to give you an imaginary line. So it's this dotted line right here. And it's imaginary because what you cannot use, or you cannot use any of these slanted sides here unless you have a right triangle. We are not going to use any of the sides as our height, which means these two are actually extra information. You don't need them. And if you see a particular problem, you might have those thrown in there just to kind of mess you up. So our height is this 9 centimeters right here. And so we're going to multiply that. I'm going to go ahead and take 1/2 of 8 first. It's going to help me out. So 1/2 of 8 is going to be 4 times 9, so that's going to make 36. So my area of my both bases here, I can do either one, is going to be 36 centimeters squared, right? Because I did 4 times 9. Each of those are centimeters. And so what I have here is my volume is going to be 18 centimeters, that's my height, times my 36 centimeters squared. And that's why our volume is always going to be cubed, or centimeters to the third, because we have 3 different centimeters here. We've got 1 here, and we've got a squared right there. So let's just do 18 times 36, and we'll figure out what our volume happens to be. So that's going to be 48. That's 60, and that's 40, so that's another 100 right there, so 10. And let's bring in this 3 times 8 is 24. And that's 3, and that's 5. So there we go. We've got 648. But remember, it's not just 648. We need the proper units, 648. We can either write cubic centimeters, or we can write centimeters with a little 3. That means centimeters cubed.